Good morning, student. In the previous lecture, we saw the introduction of MOSFET and circuit symbol of MOSFET. Now, in this lecture, we will see the working principle of MOSFET. So, this is the diagram of P-channel MOSFET and N-channel MOSFET. So, in P-channel MOSFET, there are three terminals: gate, drain, source, and one more terminal is substrate. Okay, so in this p-channel, the drain terminal and the source terminal are p-type and substrate is a n-type semiconductor. So this is the gate terminal G, and this is the layer of silicon dioxide layer, which is the insulating layer that avoid the contact of gate terminal and this p-type semiconductor material. Okay, so in n-type n-channel MOSFET there are also four terminal: gate terminal, drain terminal, source terminal, and substrate. So in n-channel MOSFET, the drain terminal and the source terminal are n-type semiconductor material and substrate is a p-type semiconductor, and gate terminal is insulated from n-type semiconductor by a SiO2, that means silicon dioxide layer. So in this case, silicon dioxide layer is a work as a insulator that avoid the contact of a gate terminal and this n-type substrate. Okay. Now the operating principle. So in the MOSFET, when gate is insulated from channel, here, so in the diagram, gate is insulated because there is no contact or no connection between gate terminal and the channel p type and n type. So negative as well as positive power supply can be applied to gate to source, that is a VGS. So the gate terminal is there is a no contact between the gate terminal and this semiconductor material. So we provide the power supply, negative as well as positive power supply. That means we provide the supply to a gate terminal, negative supply as well as positive supplies to get to source voltage. So we connect the supply between gate terminal and source terminal. So in between these two terminal, we provide a voltage. Either we provide positive voltage or we provide negative voltage, and that voltage is called as a VGS. VGS means gate to source voltage. VGS means gate to source voltage. When the gate voltage is a negative, that means when the gate voltage means what, VGS is a negative, the mode of operation of MOSFET is a deflection mode and the voltage is a greater than zero means positive, then the operation of MOSFET is called as the enhancement mode operation. So this is the gate terminal and this is the source terminal of MOSFET. So in between these two terminal, gate terminal and source terminal, we provide some voltage. Either we provide a positive voltage or we provide a negative voltage. If we provide the positive voltage, then the mode of operation is enhancement MOSFET, and if we provide the negative voltage, then the mode of operation is called as a deflection mode. Once again I repeat, when gate voltage, that means VGS is what, gate to source voltage that we provide between gate terminal and source terminal. If we provide the voltage between gate terminal and source terminal is a negative, then the mode of operation of MOSFET is a deflection mode. And if we provide the voltage between gate terminal and the source terminal is a positive, that means VGS, gate to source voltage is positive, the mode of operation is enhancement mode. Okay, so metal gate and the semiconductor channel form a parallel plate capacitor. Here, this gate this gate terminal and this is the channel drain and source channel. So this plate and this channel is working as a parallel plate capacitor. Why parallel plate capacitor? So in capacitor there are two plates, plate 1 and plate 2, and these two plates are separated from a insulating material. These two plates are separated from a insulating material, or on that both the plate there are some charge. So in this way, so this gate, and this channel also operated as a parallel plate capacitor because this gate and this channel are separated by a insulating material. So if we provide the voltage on gate to source terminal, so this construction, this arrangement is work as a parallel plate capacitor. So this arrangement is same as a capacitor because capacitor also have two plates, plate 1 and plate 2, and these two plates are separated by insulating material. Same condition is here. Gate and this channel, those are connected to parallel, and there is a insulating material between gate and channel. Okay. So the metal gate and semiconductor channel, that means this metal gate and this channel form a parallel plate capacitor, and CO2 layer act as a dielectric between two electrodes of capacitor. In similarly, the capacitor also have two plate, and this in between these two plate there are some dielectric material or insulating material. So same manner the gate and channel are separated by a this dielectric material. Okay, so the input impedance of the MOSFET is very high, in the range of 10 raised to 10 ohm to 10 raised to 15 ohm, which is achieved because of the silicon dioxide layer between the gate and channel. So the input impedance of the MOSFET is very high as compared to the BJT because of here we use a silicon layer as a insulating material. So because of that, the input impedance of MOSFET is a very high, which is in the range of 10 raised to 10 ohm to 10 raised to 15 ohm. With this fundamental information, the deflection mode and enhancement mode operation of a MOSFET can be studied. So depending upon these two voltages that we applied across the gate terminal and source terminal, the MOSFET have two operating mode: deflection operating mode and enhancement operating mode. If we provide the positive voltage to gate to source terminal, listen carefully, if we provide the positive voltage to gate and source terminal, then the mode of operation is called as a enhancement mode. And if we provide the negative voltage between gate and source terminal, then the mode of operation is called as a deflection type MOSFET. Okay. Now we see the enhancement MOSFET. When VGS means what, get to source voltage, is applied to MOSFET, is a operation is enhancement MOSFET. To understand why it is called as enhancement MOSFET, consider the circuit diagram as shown in figure. So this is the circuit diagram of enhancement mode MOSFET. So positive gate voltage enhancement MOSFET. So this is the MOSFET, this is the gate terminal, this is the drain terminal, this is source terminal, and this is the substrate. Okay, so this is the N channel MOSFET. This diagram represent that this MOSFET is N channel. Why it is N channel? Because source and drain terminal is N type semiconductor. That means channels are N. So therefore it is called as a N channel MOSFET. So here we provide the gate to source voltage is positive. That means positive terminal is connected to a gate terminal and negative terminal is connected to a source terminal because source is a N channel. Source is the N channel and N channel is the negatively charged. So if here the negative terminal of battery is connected to the N type, so therefore it is a positive voltage because the positive is connected to gate terminal and negative is connected to the N channel. So this is the gate to source voltage. Now we connect another voltage source to a drain terminal and source terminal. We connect another voltage source to a drain terminal and source voltage, which is called as a VDS. VDS is nothing but a drain to source voltage. VDS is nothing but drain source voltage because this voltage source is connected between drain terminal and source terminal. This is the drain and this is the source. So therefore this voltage source is called as a VDS. VDS means drain to source voltage. The positive terminal of supply is connected to the drain and negative terminal of supply is connected to a source terminal. Okay, id represent the drain current, is represent the source current, and ig represent the gate current. Once again I repeat, this is the MOSFET, this is gate terminal, this is source drain terminal, this is source terminal, and this is the substrate. This is the n channel MOSFET. Why it is n channel? Because the drain terminal and the source terminal are the n type, are of n type. Okay, so here we provide the positive voltage to a gate terminal. That means positive terminal, the positive terminal of supply is connected to the gate, and negative terminal is connected to a source. VGS means gate to source voltage. Okay, now we use another voltage source which is called as a VDS. Why VDS? Because this voltage source is connected between drain terminal of MOSFET and source terminal of MOSFET. So VDS means drain to source voltage. The positive terminal is connected to drain terminal, and negative terminal of supply is connected to a source. IG represent gate current, IS represent source current, and ID represent drain current. Okay, so this is the enhancement MOSFET induced channel. Then how the channel is formed between source to drain? So here there is no connection between source and drain. So how the channel is formed? So the substrate is the ground, and if VGS is 0, the substrate is ground and VGS is 0, then there will be no drain current flow if the yeah, current flow, even if the voltage is applied between the drain and source. That means the gate voltage is 0. This substrate is connected to ground. This substrate is connected to ground, and this gate voltage is 0. If the gate voltage is 0, so there is no current flow through a drain terminal even if we apply the VDS voltage. So if we apply the, even if we apply the gate drain to source voltage, there is no current flow through a drain terminal because the gate to source voltage is 0. The drain current is a flow only when the gate voltage is positive. There is some value across the gate voltage, then and only then the drain current is flow. So in substrate is ground and VGS is 0, there will be no drain current flow even if we apply the drain to source voltage. Okay. So in MOSFET, the gate form a capacitor with a gate as one plate and channel is another plate. So in MOSFET, the gate and channel is work as a capacitor. Gate is operated as one plate and this channel is operated as another plate. Now shown in figure A, the positive VGS is applied to the gate, making it positive with respect to source. So positive voltage is applied across the gate terminal and negative voltage is applied across the N terminal. Okay, so source terminal. So gate is a positive and source is negative. So gate become positive and source become negative. Okay, so the positive charge on the gate will repel hole and P substrate immediately under the gate. So here the gate become positive. If gate become positive, then it repel the positive charge and it attract the negative charge. It attract the negative charge. So here gate terminal is positive, and positive and negative get attract to each other. Positive and negative attract to each other, that means opposite charge attract to each other. So at the gate terminal there are positive charge. Why positive charge? Because we provide a positive supply to a gate terminal. So at the gate there are positive charge. So that positive charge attract the negative charge. That means it attract the electrons and repel the holes. Electrons are negatively charged and holes are positively charged. So at the gate terminal there is a positive charge, and this positive charge attract the electrons and repel the holes. Okay, so the positive charge on the plate will repel the hole from the P substrate. Similarly, electrons from the source are also drawn below the insulating silicon dioxide layer under the plate in this diagram. So this is the p type substrate. So if we provide the gate to source voltage, the positive charge will accumulate on the gate. So why positive charge? Because here gate to source voltage is positive, gate to source voltage is positive, so gate is positive, so gate is positive. So if the gate is a positive, then gate attract the negative charge. That means it attract the electrons and repel the holes. It attract the electrons and repel the holes. So all the electrons in this channel, all the electrons this in all the electrons in this n type channel will accumulate near the gate. So that shown in this figure, all the electrons are attracted towards the gate. So that means all the electron present in this n channel attract towards the gate. That means that there is a layer. So there is a layer formed near the SiO2 layer, near the silicon dioxide layer. There is a layer is formed, electrons layer. This layer is called as the electrons layer. So similarly, electrons from the source are also drawn below the insulating silicon dioxide layer under the gate. So the electrons from source, once again I repeat, the here we apply the positive voltage to gate and source. So gate terminal is positive and source terminal is negative. So positive charge will accumulate on the gate. So this positive charge attract the electrons and repel the holes. So all the electrons in source terminal, all the electrons in source terminal will attract towards the gate, will attract towards the layer. So all the electrons in this source terminal will accumulate near this. All the electrons, all the electrons from source terminal will accumulate towards the gate. That means near this insulating layer. Okay, this diagram show that all the electrons from the source terminal will accumulate near the SiO2 layer under the gate. Okay. So thus a small n-type channel is induced between source and drain as shown in figure. So as shown in figure B. So in figure B, so because of the layer, because of the electrons layer is a form. So this layer is a form between drain, source and drain. This layer is a form between source and drain. So because of this layer, because of this layer, there is a contact take place, there is a contact take place between source terminal and drain terminal. So in figure B, there is a no contact between source and drain, there is no contact between source and drain terminal. But if we apply the positive voltage to a gate terminal, so gate become positive, and because of this positive, this gate attract electrons. So all the electrons from the source terminal is accumulate near the gate, here near the gate, and because of this electron layer, there is a contact, there is a contact take place between source terminal and drain terminal. That means the new channel is formed between source and drain terminal. New channel is formed between source and drain terminal. The small n-type channel is induced or is produced between the source and drain. So this induced n-type channel is responsible for the current flown in a drain to source circuit when voltage is applied to these two terminal. So because of this channel, because of this channel, the current will flow from source to drain if when we apply the VDS, when we apply the VDS. So because now here the contact is formed between source and drain, here the contact is formed between source and drain. So there is a current flow from source to drain because of this VDS, because of this voltage source we apply. Okay. So thus positive gate voltage increase the number of free electron through charge. Hence the channel conductivity is enhanced. So that is the reason why positive gate voltage is called as the enhancement mode operation, because it enhances the channel. Because it enhancement is induced, it produce the channel between source and drain. That means it create the contact between source and drain. So after creating the contact, or after creating the channel between source and drain, the current will flow through source to drain, and this current is called as a drain current. The channel is a form between source and drain, and if we provide the VDS voltage, so if we provide VDS voltage and here the channel is formed, then the current will flow from source to drain, and this current is called as a drain current. But if gate to source voltage is zero and we provide the VDS, the gate to source voltage is zero and we provide the VDS, but there is no current. Why? Because if the gate to source voltage is zero, then no channel is formed between source to drain. There is no channel. This channel is not present if gate to source voltage is zero. If gate to source voltage is zero, then there is no channel between source and drain terminal. So even we apply the VDS, there is no current flow through a drain terminal. There is no current flow through a drain terminal because this voltage is zero. So because of this voltage is zero, there is no channel between source and drain. So if the gate to source voltage is positive, then and only then this channel is created. Why? Because when this voltage is positive, the positive charge is present on gate, and that positive charge attract the electrons. So all the electrons in source will attract toward the gate, and it form the electrons layer. That means it form the channel from source to drain, and current will flow from source to drain because of this VDS is connected. Okay, so that means hence channel is conductive is enhanced. That means if the channel conductivity is enhanced, that means the channel is created. Therefore, it is called as a enhancement mode operation. The smallest gate voltage in at which the induced channel is formed, the smallest gate voltage at which channel is formed is called as is a form, and the current can flow in a drain source is called as a threshold voltage. Threshold voltage, which is the threshold voltage? The voltage at which the channel is a form between source to drain. The channel is a form between source to drain. This voltage is called as a threshold voltage. The gate to source voltage channel is formed when gate to source voltage is positive. If we increase the positive voltage, so at particular positive voltage the channel is formed between source and drain. So at that voltage is called as a threshold voltage. That voltage is called as a threshold voltage. Once again, I repeat, we provide the positive voltage to gate terminal. So after providing the positive voltage to gate terminal, all the electrons in source will accumulate near the gate because this positive voltage or positive charge attract the electrons negative charge. So electrons is accumulate near the gate voltage, and this there is the electron layer if it form. That means the from source to drain a channel is a form. The channel is formed, but at particular voltage if we apply the positive voltage and if we increase the voltage, then more number of electrons will attract towards the gate. More number of electrons will attract towards the gate. So at a particular value of VGS, all the electrons in source terminal attract towards the gate and form a channel between drain to source. So at a positive value of VGS, the channel is formed between source to drain. So that particular voltage is called as a threshold voltage. So increase the gate voltage beyond threshold voltage will increase the drain current further. So in MOSFET operation, the specification VT means threshold voltage, is important when it is used as a switch. Okay, so what is the threshold voltage? So threshold voltage is a voltage at is a gate to source voltage. Threshold voltage is a gate to source voltage at which the channel is formed, is called as a threshold voltage. So therefore this operation is called as the enhancement operation because it enhance or it produce the channel between source and drain terminal. So after producing source to drain channel, the current will flow through a MOSFET and that current is called as a drain current. So this is the working principle of enhancement MOSFET. So now we will stop here. In next lecture we will see the operation of depletion MOSFET. Now we stop here.